Hello. In this video, we'll talk about the logic of dummy coding categorical variables in regression. We'll have another short video that talks about logic of contrast coding, and then we'll have videos that show SPSS. I can't figure out how to have a longer video than about 15 minutes, so we'll do it in 4, and then you can really parse out what you want to see. So we need to code categorical predictors because these are nominal variables. So numbers are just assigned arbitrarily. If you look at this example, this is actually question 46 from the data set we've been using in class, the Youth Risk Behavior Surveillance data set. And this is question 46, and I trimmed down the category. So this is the source of the child's alcohol. And we have 3 categories. They didn't drink in the past 3 days, they bought, took, or stole, or they were given alcohol. So 170 happily did not drink because these are children. 42 bought, took, or stole. 33 were given. So we have a total sample size of 245, and 55 people are missing data. Children are missing data. Clearly, it doesn't make sense. If this was in the original variable, code at 1, bought, took, sold is code at 2, given is sold is code at 3, well, it would make no sense in correlation to say, gee, as source of child's alcohol increases, number of drinks increases. That's not sensical. Hence, we need to code. So we have 3 categories. And to uniquely code this variable with 3 categories, we need 2 new variables. In dummy coding, there are lots and lots of ways to code in regression, and probably dummy coding is the most popular, but there are lots of others. And essentially, dummy coding compares each group to a reference group. So step back for a minute and think in your own research when that makes sense to do. Sometimes there might be a logical reference group, and sometimes there might not. So the idea is not to do this mindlessly, but to think, carefully about your decision choices in how you're creating these dummy codes. So in this example, let's scoosh this down a little bit. In this example, what's a logical reference group? Well, did not drink in the last 30 days seems pretty logical. I should note, this is not great science at all in substance use and abuse, but it works for the example. So we had 170. I think the textbook talks about using a category with the largest n, which is fine, but this also makes sense substantively. I think that's the bigger issue, substantively. So I'm going to take this out so we don't ruin the surprise in how we do this. So we'll say, let's make this the reference group. Well, we need 2 dummy coded variables. So the first one, let's put a 0 in for the dummy code. And we could compare bought, took, and stole to that. We'll give that a 1 and then a 0. So in this comparison compares kids who bought, took, and stole to those who did not drink on a DV to be named later. Then we need 1 more to uniquely define this variable, so we can have if they were given alcohol or not. So again, this is the reference group, so it gets a 0. And bought, stole, took, well, we've used that already. That's not the goal of this variable, so it's a 0. And then given alcohol, well, we care about this one. So this vector or variable compares given alcohol to did not drink. So take a look. Did not drink is, each of these is uniquely coded now. So did not drink is coded 0, 0, and that's different coding than bought, took, stole, which is coded 1, 0. And that's different from given alcohol, which is 0, 1. So if you look at the regression line, and let me just make this larger so you don't have to squeeze up your eyes to look at. So we know that we predict a score, and that's the intercept plus slope times x1 plus the slope times x2. And we're predicting a score in multiple regression, in ordinary least squares regression. And if we have all categorical variables, then we're predicting a mean, which is fantastic. And just to show that it works, we'll take a look. So we know that the intercept with dummy coding is the mean of the group code at 0, did not drink. So we plug in a 0 for x1, this right here to here, a 0 for x2 here, and well, those cancel. Obviously, we're left with y predicted equals the intercept. Perfect. So this is a nice method if indeed you have a reference group. It's perfectly lovely. It's also the most common method to do. In an upcoming video, we'll take these codes and put them into SPSS. I'll show you how to recode the variable and then run the analysis. And as always, keep me posted on what's helpful and what's not as helpful. Great. Well, on to the next one.